What the F is going on with our planet right now? The NOAA announces a severe hurricane season. Now, it was severe last year as well, and we've seen the uptick in strength and frequency of hurricanes go up. We are currently seeing magnitude 5 and 6 earthquakes are a regular occurrence. This is almost daily, if not on a weekly basis. We're also seeing an increase in volcanic activity. For example, in areas like Santorini, Greece, in Campi Flegrei in Italy, or the axial seamount underwater volcano off the coast, the west coast of the United States. We're also seeing a constant increase in our ocean's temperatures. We're also seeing the fact that our ocean is nearly dead due to the pollution of plastics. And we have also seen an increase in the strength of tornadoes. For example, Kentucky just got slammed by a wave of tornadoes that took some lives. Now, we're going to go into why all of this is happening. Remember, this is for entertainment purposes only. And we're going to start with, so here's our galaxy. Every 12,000 years, our galaxy passes through a cosmic radiation. Let's call these red lines this cosmic radiation. At the 6 p.m. mark and at the 12 p.m. mark on our galactic clock, this cosmic radiation exists. Every 12,000 years, so we have 12,000 years on this side, then we have 12,000 years on this side, we pass through this galactic energy. And this energy charges the cores of all planets. So if you notice the activity of our sun, if you look at the activity of Mars and other planets just like ours, all the cores are currently charging, and it's causing these rapid effects that we are seeing right now. So let's go ahead and get to our planet. So here's planet Earth, here is the Earth's core, and here is the crust of our planet. Now imagine, as this cosmic energy hits our core, it starts to heat our core from the inside out, and this energy causes rapid magma rise. Now, as this magma starts to rise to the surface, okay, what do we get? We get an expansion of our Earth's crust. It starts putting pressure on the crust, causes earthquakes. What do we also simultaneously see? Well, there are little holes where the magma can seep through, and this is where volcanoes get formed. What do we also see? Well, in the areas where we see these plumes, the magma starts to rise and hits the crust, but then it doesn't penetrate the crust. It actually plumes outward. For example, Siberia. Siberia has one of the biggest magma plumes on the entire planet right now. And 250 million years ago, this was one of the world's biggest extinction events, known as the Siberian Traps. The blue line here is the ocean. Here is the Earth's crust. Here is the ocean. Right, this blue right here represents the ocean. Rapid magma rise. What do you guys think is going to happen to our Earth's oceans? It takes this heat and it dissipates this heat into space. Okay, we're into the atmosphere. We are dealing with a blanket of microplastics. Now what this does is it affects the ocean's thermoregulation capacity, and the heat winds up getting trapped within the ocean. Moisture in the atmosphere winds up getting trapped due to all of these little nanoparticles of plastic. In terms of atmospheric moisture, it increases it. Warmer oceans, more moisture within the atmosphere, hurricanes in strength and frequency, tornadoes, flash floods, all of these sorts of things. Let's go back to the magma pools. We have our Earth's crust, a rapid ascent of magma that pools out like this. Okay, this is the magma sitting at the edge of the Earth's crust. There are secondary chambers of magma, and it is very easy to drill holes in the Earth's crust to start releasing the magma in a controlled way, right? So you drill into these secondary chambers and you release the magma onto the Earth's crust. This takes pressure off of our Earth's crust and can help mitigate the strength of earthquakes worldwide. Now let's take our oceans. What happens when you take the microplastics out of the ocean? Rapid magma ascent, our oceans. Here is the atmospheric moisture. Now we take all of the microplastics out of the ocean. So we got a lot less here, and we have a lot less here. Now we use atmospheric water generators. Atmospheric water generators, they take the moisture out of the atmosphere, filter it through a system, and pull the nanoparticles out. As this moisture, with these nanoparticles of plastic, continue to make its way into the air, it gets pulled into the machine and it gets filtered through the machine. And then out comes clean drinking water, right, for everyone to drink that is free of these particles. Over the course of a few years, our oceans become cleansed of these nanoparticles. The ocean goes back to its normal function, and the rapid magma rise no longer affects the Earth's crust as much due to the degassing of the Siberian magma plume. All of this information has been explained and presented and scientifically proven by the ALLATRA International Public Movement. Okay? ALLATRA IPM has been studying these issues for the last 20 to 30 years. So can we stop our planet from going through this cosmic radiation? No. But can we mitigate the effects that it has on our planet? Absolutely.